Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems we want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Math Night. I'm so happy to be back. I'm so thankful that Priya did an amazing job last week. Unfortunately, our entire family had COVID, so we were down for the count, but we are back and healthy as ever. So thank you so much to Priya for covering down for me last week. It's good to see you all. It's good to be back. I love Wednesday nights with you. This week, we're kind of doing something a little different. We're doing data and statistics. We don't usually spend a whole lot of time on data and statistics. We usually spend the bulk of our time together on geometry, algebra, and things like that. But this week, I really wanted to kind of focus on a section that we kind of forget about, but a lot of us really need help with it. So that said, before we get started, let me know in the comments section where you're from and what test you're prepping for. That helps me kind of guide our conversation tonight. Even though the questions are set, it kind of helps me understand who's in the room and the rabbit trails that we can go on. Also, in the comment section, let me know where you went to college or are currently in college. I went to UCF repping the Knights. So we are a split household. My husband went to USF. I went to UCF. So it's an interesting household during football season. Not that either of our teams are really that great, but that's okay. So let me know in the comments where you're from, what test you're prepping for, and what college did you go to or are you currently at right now. Without further ado, I'm going to go ahead and get started with our first problem tonight. So let's get started. Let's not waste any time at all. Prepping for the FTCE exam. Awesome. All right, problem number 1. Welcome, welcome, FAU. Awesome. It's good to see you guys. The average lifespan of an elephant is 65 years with a standard deviation of 12 years. Which of the following is the best interpretation regarding the previous statement? A, the median lifespan of an elephant is 65 years. B, Most elephants live to be older than 53 years. C, most elephants live to be between 77 and 89 years. Or D, the longest living elephant lived to be 101 years. So when you see a standard deviation question like this, they're not asking you to actually find the standard deviation. In fact, on most exams, they're not going to ask you to actually calculate the standard deviation. They want you to be able to interpret what standard deviation means. So that said, if we were to look at a graph with standard deviation just describes how data is typically distributed across a graph. So if these are my axes, and I'm going to change colors here, if these are my axes, and I have data distribution that looks something like this, where the black line is your median or the middle of your data, what standard deviation says is at one standard deviation away, we're looking at about 34% of the data is going to fall between your median and one standard deviation away from it. And that first standard deviation goes to the right and the left of your median value. And then after that, you have your second standard deviation, your third standard deviation. And as those standard deviations get further and further and further away from your median, there's a smaller percentage of data that happens within that percentage. So when we look at this, if this is all they've given us, is that the average lifespan is 65. So 65 is going to go right here, which is our average. And we have a standard deviation of 12. That means that I can add 12 for each of these standard deviations to 65, and I can subtract 12 from 65 to get a value for each of these standard deviations. So if I use my handy dandy calculator, 65 plus 12, that gives us 77 here, 89 here, and 101 here. Then if I subtract 12 from 65, I get 53 for this data point, 41 for this data point, 29 for this data point. So that means when I see that, that means that I have my average in the middle, and then one standard deviation is 12 years. So 34% of my elephants approximately are going to be between 65 and 77. And then another 34% of my elephants are going to be between 53 and 65 years old. And then it tapers down from there. This would be a question on GK math. And why is it 34%? Because data analysts figured that out. One standard deviation away from that middle point is going to be approximately 34%. So one standard deviation is 12, 2 sigma is 12, and 3 sigma is 12. Well, each standard deviation is 12, so I'm adding 12 each time to that data point, and then I'm subtracting 12 each time from that middle data point. So how do we interpret this problem? Because this problem really isn't that complicated when we look at these answer choices. The median lifespan of an elephant is 65. So I actually need to correct myself. From the beginning of this video, I said that that black line is the median. It is not. It is the mean. It is the average. That's why I erased it. We don't know the median of the elephant. They gave us the average, but we don't know what the actual median is. They didn't give us any data, so I can't figure out the median or the mode or the range. I don't know what the oldest elephant is. I don't know what the youngest elephant is. I don't know any of that. They didn't give us a table of values that say, here are all of the ages of the elephants. All they told us is the standard deviation. So I don't know the median, and I don't know who the oldest elephant is, and I don't know who the youngest elephant is. Even though technically, when we look at standard deviations, this is kind of where we stop. That doesn't mean that there can't be a really old elephant over here. It just means that that's where the 100% of the elephants happen. How would I know that the 12 years is not at the tail? It doesn't specify that the standard deviation is 12. It does specify that the standard deviation is 12. They told us with a standard deviation of 12. So I'm not entirely sure what your question is. Sorry, if you can clarify that. Like, they said the standard deviation is 12, which means one standard deviation away is going to be 12, and then 2 is going to be 12, and then 3 is going to be 12. So I'm subtracting 12 each time here, and then I'm adding 12 here. So for advanced statistics, you are absolutely right. This problem is technically written for a 4th through an 8th grade test. So for statistics on a 7th through 12th grade test, yes, you are correct. For a statistics problem on a 4th through 8th grade test, this is all they're going to see. So they just have to be able to interpret this. We can talk more later. All right. So most elephants live to be older than 53. So if I'm looking at that, the elephants that are older than 53 are going to be here and over. So it's going to include the 34% here. It's going to include the 34% here. It's going to include the 12% here and the 2% here. Is that most? Yes, that is most. Because when we look at the most amount, I'm looking for the percentage that's over 50%. And if I have 34% and then another 34% and then 12 and then 2-ish, then that's going to be most of my elephants. Now, most elephants live to be between 77 and 89. Between 77 and 89 is right here, and that's only approximately like 12 to 14% of my data. So that's absolutely not going to be the correct answer. So therefore, B is the correct answer. Do I subtract for 100% to get 34? No, I literally just took what we know to be true about a bell curve, which is that one standard deviation away is about 34% of your data on either side. 2 standard deviations away is about 12 to 14%, and it keeps going down from there. All right. That's that problem. Let's keep moving on to other problems. Students were measuring how much water can fill a large jug and how long it would take for the water to fill the jug. Which of the following would be the best choice to represent this data? So we have to understand what kind of data we're representing. We have how much water and how long it would take for that water to fill the jug. So we have 2 numerical values. We have a amount and we have a time. When I think about an amount and a time on the same graph, I'm immediately thinking about a line graph. And here's why. When we look at a line graph, we're looking at a graph that looks something like this. So I've got time on my x-axis, and I have the amount of water on my y-axis, because the amount of water depends upon the time. What does that mean? That means that the amount of water is my dependent variable and the time is my independent variable. So when I'm looking at that graph, I know that a line graph is going to do the best job representing a graph that looks at an amount over the course of time. But let's talk about what a histogram, a pie graph, and a box and whisker plot are so that we can better understand why the line graph is the best. So what is a histogram? A histogram is kind of like a fancy version of a bar graph. So a histogram is going to look something like this. And I'm going to have bars that are connected. And each of those bars is going to represent a different stretch of numbers. And then the height is going to be, how much water or whatever. Could this be used to represent that data? It could. I could put like from 0 to 2 hours, how full is my jug? I could put from 3 to 5 hours, but it's really not the best use because I want to be able to see how full the jug is over the course of time. I don't want just from 0 to 2 hours and only see one number. I want to watch how that jug is progressing. So that's why a histogram is not going to be the best. However, a histogram is one in which you do need two numerical values. A pie chart. A pie chart is going to be best when we're looking at a whole. So like a percentage of a whole. That's going to be what a pie chart is, and that's definitely not going to be what this is. A histogram also does have to have equal intervals. You're absolutely right. So when I look at that, actually, I'm going to erase that and just copy this one. So when I look at this histogram, these intervals have to be equal. So if I'm going to do a span of 0 to 2, then I would do from here, it would be from 2 to 4 or 3 to 5. Sometimes histograms do either or, but I can't then do like 5 to 12. They have to be equal. You're absolutely right. Thank you for clarifying that, Joseph. A box and whisker plot is not going to be appropriate for this either because a box and whisker plot is one in which we're looking at a range of data. So we're looking at our Q1, our Q2, our Q3, and our Q4. We're looking at an interquartile range. And so that's not going to be the best option for the representation of this data either. Line graph is going to be our best bet. And line graph is absolutely going to be our best bet when we're looking at something over the course of time. So when I'm looking at water over time, or I'm looking at miles per hour, all of those would be excellent uses for a line graph. All right, let's keep moving. Let's look at some interpretations of graphs now. This is a great one for my K through 6 people. So the next two are going to be great for my K through 6 people. A second grade class took data on their favorite ice cream flavors. How many students were surveyed? So here's my graph of favorite ice cream flavors. This is going to be a bar graph. Why is this not a histogram? It's not a histogram because I do not have numerical data on the bottom, and it's not equal intervals. I have labels on the bottom. So that's why this is not a histogram. They asked us how many students were surveyed. Well, if 12 people like chocolate, 5 people like vanilla, seven people like strawberry, and 2 people like another flavor. How do I figure out how many people are surveyed? I'm just going to take those values and I'm going to add them together. Now, how do I know that that's 5 and 7? Because this is exactly equal between the 6 and the 4. And this is exactly equal between the 8 and the 6. Now, people can't be like a fraction of a person. So I'm not going to see a graph that's going to look like this because I can't have 3.8 people surveyed. So in this kind of scenario, we know that we're going to be only dealing with whole numbers because of the type of data that we're looking at. If this was how many gallons the ice cream store still has after they sold ice cream on Friday night, then I could have fractional parts of gallons. But because it's people, I can't. So how do I figure out how many people were surveyed? I'm going to add all of these people up, and it'll give me my answer. So 12 plus 5 plus 7 plus 2. 5 plus 7 is 12. So I have 12 plus 12 plus 2. 12 plus 12 is 24. And 24 plus 2 equals 26. So for this question, D is going to be the correct answer. Thank you, Joseph, for clarifying that for Milagros. If you still have questions, please let me know and I can explain it. But I think Joseph did a great job explaining that. Thank you. All right, let's move on to the next question. It's the same graph. We're just answering an additional question about that graph because I wanted us to be able to use the same graph to prove that a lot of different questions can be asked about one graph. So here's the same graph with the same values of people who like chocolate, strawberry, vanilla, and other. How many fewer students chose vanilla than chocolate and strawberry combined? How many fewer students chose vanilla than chocolate and strawberry combined? Well, when we're looking for how many fewer, we're looking for the difference between two different values. I'm looking for the gap between two different values. Well, what are those two values? It's not vanilla and chocolate. It's not vanilla and strawberry. It's vanilla and it's chocolate and strawberry combined. I'm not going to add vanilla and chocolate and strawberry because I know that this problem is asking me for how many fewer, which means I know I'm looking for my difference. But that said, I'm going to subtract vanilla and chocolate and strawberry combined. So let's review. We know that we have 12 students here, 5 students here, 7 students here, and 2 students here. I know I'm looking for vanilla and chocolate and strawberry combined. So I'm going to use a different color for that. Vanilla and chocolate and strawberry combined. So how many vanilla are there? There are 5 vanilla. How many chocolate and strawberry are there? Well, chocolate plus strawberry is 12 plus 7, which equals 19. So I'm going to subtract 19 minus 5. Why am I not going to do 5 minus 19? Because that would give me a negative value, and that's not what it asked us for. 19 minus 5 equals 14. So to answer this question, there are 14 fewer people that chose vanilla than chocolate and strawberry combined. I have 2 questions about this problem as well. So let's go ahead and read it. A high school band is practicing for the upcoming holiday parade by marching around the school. Their practice route took them an hour and a half from start to finish, including the time that they were marching in place while waiting for their turn to move forward. How many minutes did it take for the band to be 1 mile away from the school? This is an interesting question because this question is not a straightforward graph like the others have been. This question requires some serious interpretation. So let's take a look at the graph. We are looking at their distance from school. So this is distance from the school, and this is the time. But they didn't define the time for us. They did not say that these are minutes or hours. These are just chunks of time. And what else do we know about this? The time that they were marching. It said that they were marching, or that their practice route took them an hour and a half from start to finish. And here's their start, and here's their finish. So what does that mean? That means that they were marching for a small amount of time in place. Then they started marching around the school. Then they were marching in place. Then they continued their journey around the school. They continued their journey around the school. Then they were marching in place. They continued until they got back to the school at 0 miles away from the school. Here's a question for you before we analyze this problem completely. What does this steep slant mean? What's the difference between that section and this section? This is from 4 to 5, and this is from 5 to 6. And we don't know how many minutes or hours that is. We just know that those are equal time blocks. What does that mean? What was happening during that time span? Well, right here, they were marching quicker, which means that they were covering more distance in a shorter amount of time. And then here, they were still marching because even when they were in place, they were marching, but they were marching slower. So they were covering less distance over the course of time. You're absolutely right, Joseph. So now let's go back to our question. The practice route took them an hour and a half. So an hour and a half is 60 minutes plus 30 minutes, which equals 90 minutes. So we know that from time 0 all the way to time 11, it was 90 minutes. And they want to know how many minutes did it take for the band to be 1 mile away from the school? Well, when did 1 mile happen? 1 mile happened right here. So it happened at the 6 mark. But again, at this point, we don't know what that 6 represents. We know that we have 11 equal spaces in our time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they were marching for 11 equal spaces. So what I'm going to do is I'm going to take my 90 minutes and I'm going to divide that by 11 to figure out what each one of those sections represents. So 90 divided by 11 equals 8.18 repeating. That means that this is 8.18 minutes. And then this is 16.36 minutes. And then this is 24.54 minutes. How am I getting that? Because I'm adding 8.18 plus 8.18 plus 8.18 plus 8.18 until I get to 11. And that's going to be my 90-minute mark. So that said, how many minutes did it take for them to be at the 1 mile mark? Well, it's going to be 8.18 times 1, 2, 3, 4, 5, 6. Sorry, my mom was calling me and I had to decline that phone call. All right, so 8.18 times 6, because there's 6 sections of that until they hit that 1 mile mark, is going to equal 49.08. So our answer is C. It's a very interesting question because a lot of times we assume that these numbers mean minutes or hours or seconds. So in this case, because it doesn't mean that, we had to figure out what each of those intervals represented. So I multiply and then add. I just added because I knew that 1 hour equals 60 minutes. So this was my 1 hour and this was my half hour, and that together equals 90 minutes. Basic conversions is what that is. All right, let's answer another question about this same graph. So it's not going to take us as long to discuss this because we've already discussed how to interpret the graph. So now we just need to answer the question. The high school band is still practicing for the upcoming holiday parade. It still takes them an hour and a half from start to finish. So we know that each of these time intervals equals 8.18 minutes. And that this is time and that this is distance. The question this time is, how many total minutes was the band stationary? What does that word stationary mean? That word stationary means still, not making distance progress. However, they can still be marching in place. So at what points are they marching in place? I'll give you a clue. It's not here. It's when the line is straight. Why is it when the line is straight? Because they're still marching. They are still a mile away from school here, but they were a mile away from school at that point. And they were a mile away from school at that point too, which means they weren't going anywhere. Their distance did not change, but they were still marching in place. So it happened between the 2 and the 3, and it happened between the 6 and the 8. So how many minutes were they stationary right here? 8.18. Because it's one time interval. How many minutes were they stationary here? 8.18 plus 8.18, which is 16.36, because it's 2 time intervals. So now I'm going to add 8.18 plus 16.36. And that gives us, ooh, did I do that right? Oh, and we also have to remember this section down here. I almost forgot it. We have to remember this section where they were stationary. They started marching for that time, but they didn't go anywhere when they first started marching. Because think about a parade. When you first start marching, you're going to be in place until the front of that parade keeps going. So this is going to be 8.182. So we have 8.18 plus 8.18 plus 16.36. And that's going to equal 32.72. And when we round that to the nearest minute, we get 33. Now, how did I know that was wrong? Because when I forgot this section down here, I got an answer of 24.54. And I can see in my answer choices that that's not an answer choice. So I immediately knew it was wrong. However, that very well easily could be an answer choice. So you always want to make sure you check your work before you keep moving. Yes, these are the same graphs, which means they are the same problem, just a different question in the problem. Because when we're looking at data and statistics, there are a lot of questions that we can ask about one graph, and that's what I'm proving here. All right. This is an interesting one. This is one of those problems that people often shy away from, or they back away from it because it's an interpretation question. It often doesn't make sense in our brain. If each value in a data set was increased by the same amount, which of the following statements is true? The mean and the range will remain the same. The mean will increase and the range will remain the same. The mean will remain the same and the range will increase. Both the mean and range will increase. So I'll go back to those problems in a minute, Milagros. So this is the kind of problem that I was never very good at because I have to have numbers to help me with this. So I personally would probably skip right over this problem and come back to it when I had the time to sit and write out some sample numbers. So let's think about this. If I have a data set, sample data set, and this is what I wouldn't write out sample data set, but if I were to do this problem, I would come up with a sample data set A. And let's say it's 3, 5, 6, and 7. And then I increase that data set by the same amount. So now my data set B, let's say I am going to add 3 to all of my data sets. So now instead of 3, 5, 6, and 7, I have 6, 8, 9, and 10. Which of the following statements is true? The mean and the range will remain the same. Well, mean takes a really long time to do. Remember, mean is the same thing as your average. So I'm not going to sit here and average them right now. What I am going to do is I'm going to look at my range because each of these has range as an option. Well, what is the range? The range is the difference between the highest and the lowest data set. Or they could ask you like what the range is between these two numbers, and then it would be difference. So I'm going to do 10 minus 4, or 10 minus 6, and the range would be 4. 7 minus 3, the range is still 4. So if I increase these by the same amount, the gap between them is going to remain the same. So C and D are out because the range is not increasing. The range is going to remain the same. Now, what's going to happen to my mean or my average? My mean or my average is going to be, well, let's just find out. How do I find average? I add them all up, 3 plus 5 plus 6 plus 7, divided by however many I have, which is 4. I have 1, 2, 3, 4 data sets. What is that going to equal? Well, 3 plus 5 plus 6 plus 7 equals 21, and 21 divided by 4 equals 5.25. Now, what's going to happen in my next data set? My numbers increased, but I still have the same number of numbers, which means that mean is going to increase. 6 plus 8 plus 9 plus 10 divided by 4 is not going to be the same as 3 plus 5 plus 6 plus 7 divided by 4. 6 plus 8 plus 9 plus 10 divided by 4 is 33 divided by 4, which is 8.25. So the mean is going to increase, but the range is going to remain the same. Now, like I told you before, this is a problem that I don't do well conceptualizing without sample numbers. So the 3, the 5, the 6, and the 7, the 6, the 8, the 9, and the 10, those are numbers I just made up in my head to create sample data sets so that I could find the mean and the range. That allowed me to really manipulate this problem and prove that B is the correct answer. Do you have to do that? No, I guarantee you there are people in this room right now who could conceptualize that without creating their own numbers. And that's awesome. I wish I was one of those people, but I'm not. And so I just made up random numbers to make this problem a little easier for me. All right, you see different wording for problem 7. It's the exact same wording from here all the way to here. This wording is the exact same. The only thing that changed is the question. So it's the same scenario. The only thing that changed is the question at the end. All right, let's keep going. This is a problem that's definitely going to be for my 7 through 12 people because everybody else does not have to find central angle. So if you're taking the GK or the middle school math exam, this is not a problem for you. This is a problem for my 7 through 12 people. As a part of a survey, 2,000 people were asked to name their favorite sport, where the table and circle graph below present the results. Find the central angle percent degree for the portion of the circle graph representing soccer and hockey combined. So this is an example of a pie graph or a circle graph. Milagros, you were asking what a pie graph looks like. This is it. It looks like a big pizza or a big pie cut into pieces. And so they're asking for the angle, the central angle of the portion of the circle representing soccer and hockey. Now, if I had no time left in my exam and I just had to pick an answer, I would pick A or B immediately. Why? Because I'm looking at my soccer and my hockey, and they are low percentage-wise in regards to the number of people. And so that tells me that this graph is slightly drawn to scale-ish, which means that it's not going to be 69. Actually, I take that back. I was looking at percentage and we're looking at central angle. So never mind. If they were asking for the percentage of out of 100, then I would be looking at that. But they're not. They're looking at the measure of this angle in degrees. And so therefore, I can't do what I was about to do. If they were looking for percentage, then that would not be 69% of my graph, because 69.3% would be greater than half. So it would be something like, I don't know, this, all of that would have to be filled. And 49.5 would be half. But that's only if they were asking for percent, and they're not. They're looking for central angle. So let's keep going. So how do I find the central angle? Well, I have to look at the number of people, and I have to find what percent this is out of the total so that I can then convert that into 360 degrees and find the percent or the angle, the actual angle measurement. So how do I find the percent? I take my hockey and my soccer people and I add them together. 110 plus 275. What is 110 plus 275? 385. Out of how many total people? Now, could I add all of these up? Yes. Why would I do that though, when they give us the number of people who were surveyed? They told us 2,000 people were surveyed. So I'm not going to waste my time adding all of those up if I don't have to. Now I'm going to use my calculator to figure out what percent that is. 385 divided by 2,000 equals 0.125. That is the percent, 19.25%. However, they asked us for central angle in degrees. And so to find the degree of that angle, I have to find what is 19.25% of 360 degrees. Where did I get 360 from? Because the number of degrees in a circle is 360. So if I'm looking for the percent that this is covering, that's going to give me that angle measurement, because there are 360 total degrees in a circle. So if I do 360 times 0.1925, that will give me the angle measurement, which is 69.3 degrees. It's not giving me the percentage. Now, does that angle make sense? It absolutely does make sense, because when I look at a 90-degree angle, I know a 90-degree angle looks something like this, which is 90 degrees. And this isn't terribly far off of that. A 19-degree angle would look something a lot smaller like this, like maybe just the hockey would be 19-ish%. So all that said, my elimination strategy would work if it was percents, but it's not. And really, if I was looking for the angle measurement and I was doing it based on how it looked, I would have probably chosen 69.3 degrees anyways. But we never, ever, ever want to do things based on the way they look, because a lot of times things are not drawn to scale. All right, let's do another one. In a bag of red and green sweets, the ratio of red sweets to green sweets is 3:4. If the bag contains 320 green sweets, how many red sweets are there? So we have a bag of red and green sweets. The ratio of red to green sweets is 3:4. Now, how do I know that the ratio is red to green and not green to red? In other words, how do I know that this is the red and that this is the green? Because when we talk about ratios, we are talking in order. So if they say the ratio of red to green, that means I'm looking at red first and then green second. Then it tells us if the bag contains 320 green sweets, how many red? So I'm looking for how many red, and they tell us that the bag has 320 green. Well, they've made our life really easy, because in this problem, I don't have to interpret anything. I can do red over green equals red over green, because when I set up a proportion, I have to have proportions that are comparing the same two things. So I have red to green, and I have red to green. 3/4 equals R over 320. R is my variable of what I'm looking for. Now from here, I have two different ways I can solve it. I can cross multiply, so I'm going to solve it both ways. So down here, I can cross multiply and do 320 times 3 equals 4R. So 320 times 3 equals 4 times R. 320 times 3 equals 960. Oops. Equals 4R. Divide both sides by 4, and I get R equals 240. I can also solve it by looking at how these proportions are set up. So I know that 4 times something has to give me 320. Well, I know that 4 times 8 is 32. So I know that 4 times 80 has to be 320. Well, if I multiply the bottom times 80, I have to multiply the top times 80 as well to give me a equal ratio. And that's really what we're looking for, is we're looking for equal ratios. 3 times 8 is 24. So 3 times 80 is 240. Both of these methods will work. You just have to choose the one that works best for you. All right, we have time for one more, and then we're going to get going. John has 30 marbles, 18 of which are red and 12 of which are blue. Jane has 20 marbles, All of them are red or blue. We just don't know how much are red and how much are blue. If the ratio of red to blue marbles is the same for both John and Jane, then John has how many more blue marbles than Jane? So we know we have red marbles to blue marbles, 18 to 12. But we do not know how many red or blue Jane has. So I can't set up a proportion of red over blue equals red over blue, because the only thing I know about Jane's marbles is that she has 20 of them, which is her total. So I have to set up a ratio of red and total, or blue and total, to red and total or blue and total. So which one do we want to use? Do we want to use red or blue? Let's use red. All right, if someone voted and said blue, I'm sorry, I just didn't see the comment yet. So I'm going to do red over total equals red over total. You're going to see why I'm doing this in a minute. So I'm going to do John first. John is going to be over here. Jane is going to be over here. So John has 18 red and 30 total marbles. Jane has, we don't know how many red, but we know she has 20 marbles. In this case, I'm going to cross multiply because there's not something easy that I can multiply or divide the 30 by to get to 20. So I'm going to cross multiply 18 times 20 and 30 are. 18 times 20 equals 360 equals 30 R. Divide both sides by 30 and I get R equals 12. That means that Jane has 12 red marbles. What else does that mean? That means I can figure out how many blue marbles she has by doing her total minus her red, and that equals 8. So she has 8 blue marbles. Now I can figure out how many more blue marbles John has than Jane. John has 12 blue marbles. Jane has 8. So he has 4 more blue marbles than Jane. That was a challenging ratio problem. All right, I'm going to turn it back over to Dr. A. If there's anything that you want to see me go over on Wednesdays, please let me know in the comments, and I will add them into our presentation for next week. Otherwise, I will continue to put together an amazing plethora of problems for all of us to work through together. And I will see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.